Welcome to EDU World Space.
So we're told a ring with a mass m is cut from a thin uniform plate, and determine the mass moment of the ring with respect to the A prime axis and the CC prime axis. So this one and this one. So to get this one, we're going to need this one. But because of symmetry, we know this one is going to be the same as that one. So we need to find area moments. And so the area moment of this cross section, we can just look it up and then subtract out the whole. So we get pi over 4 r2, the outer radius here, to the fourth, minus r1, the inner radius, to the fourth. And that also equals the area moment about this axis. Now the area is pi times r squared minus r1 squared, okay, from the area here. So the area of the total minus the cutout hole. The mass is the density times the volume. So we can write the the mass moment is rho t times the area moment, and rho t is just the mass over the area, so the areal density. So we get this expression here. Then we can substitute in here for the area, and we get we see our pi's cancel out, and this expression here we can factor this into r2 squared minus r1 squared times r2 squared plus r1 squared, and then the r2 squared minus r1 squared terms cancel out. So this just becomes this term here becomes r2 squared plus r1 squared, as then we have an m over 4 in front. So we get that here is our mass moment, and the about the other axis here is the same. And so about this axis is the polar area moment, which is the sum of these two things, which is just double one of these. And so we get, instead of m over 4, we get m over 2. Now first you might think it's kind of weird to have a plus sign in here because you're subtracting out area, but remember that these are squareds, not fourths. So it's just because of the math that we wind up with the plus sign in here, where it looks like we're adding up pieces instead of subtracting off a piece.